Hello everyone. Today we will be beginning our discussion of apportionment. Now, what is apportionment? Well, apportionment is basically where we have a certain number of identical individual objects that we are trying to divide among some number of people or entities based on some kind of criterion. So the classic example is apportioning legislative seats. So this is where you have some number of seats in your legislature and you're trying to apportion those seats between however many states based on usually the populations of those states. So when we're dealing with apportionment problems, we use those terms sort of generically: states, seats, and populations. They don't necessarily have to be actual states or actual legislative seats or actual populations. But in general, the states are who we are apportioning the seats between, and the populations are whatever we are using as the basis for our apportionment. Now, what are some other scenarios besides legislative seats where you might use apportionment? Well, there could be something like maybe allocating classrooms at a college between departments based on the number of class sections that each of those departments has. Or it could be something like you are allocating maybe garbage trucks to neighborhoods in a city based on the population of those neighborhoods. These are all instances of scenarios where apportionment could be used. So we will look at an example of what an apportionment problem looks like. So in this case, we have a country that we have just sort of made up. We have 5 states. We're just going to call them A, B, C, D, and E. We use N to denote the number of states. So this would be N equals 5. We use M to indicate the number of seats we have. In this case, we're told that we have 100 seats that we are trying to apportion between these 5 different states. And we are given the populations of these 5 states, which conveniently add up to a total of 100,000. So when we are figuring out how to apportion seats, the sort of starting point here is to calculate what we call the standard divisor. And all the standard divisor is just our total population, which we use capital P for this, divided by the number of seats. So in this case, that would be 100,000 divided by 100. So our standard divisor in this case would be 1,000. Now, once we have the standard divisor, we actually can use this to determine theoretically how many seats each state should have if we were using exact amounts, including potentially fractional seats, if that were allowed. So what we call this is the standard quota. The standard quota basically is just our population of the state. We use lowercase p for that, divided by the standard divisor. So if we go down the line here, for A, our population is 4,900 divided by our standard divisor of 1,000. That gives us a standard quota of 4.9, 31.2 for B, 38.6 for C, 15.7 for D, and 9.6 for E. So this is a pretty clear illustration of why we need some kind of apportionment method to figure out how to split up seats, because obviously we can't give state A 4.9 seats. You can't give someone 4.9 seats in a legislature or 31.2 seats in a legislature. It just doesn't make sense, right? So this is why apportionment methods are necessary. Now, one other thing about standard quotas is that you cannot simply round all of the standard quotas to the nearest whole number and make the apportionment immediately based on that. If we did that, I'm just going to write the rounded values in the corners here. So for A, that would be 5, 31 for B, 39 for C, 16 for D, and 10 for E. So if we add all of those up, then what we actually end up with is 101. So we have 101 seats that we would be giving out to these 5 states based on just the rounded standard quotas, but we only have 100 seats. That's why this is a problem. So just rounding the standard quotas as an apportionment method does not work. All right? So a couple of concepts that we'll use for some of the apportionment methods that we'll talk about in the next few videos are what we call the upper quota and the lower quota. So all that those are, the upper quota is just the standard quota rounded up, the lower quota is just the standard quota rounded down. So for A, we have 4.9 as our standard quota, so upper would be 5, lower 4. B, upper quota 32, lower 31. C, 39 and 38. D, 16 and 15. And E, 10 and 9. We'll talk about several different apportionment methods, but several of the ones that we'll talk about use either the upper quota or the lower quota. Thank you for watching, and if you have questions about any of this, I am of course happy to help.